In this section, we continue on how pipelines are built with steps 15 to 21.
Borrow pit and aggregate preparation pipeline construction often requires aggregate, sand, padding material, road material, and other support materials. Borrow pits may be developed to provide suitable material for access roads, trench padding, backfill support, drainage, stabilization, or temporary construction surfaces. Aggregate processing may be required to crush, screen, sort, or prepare material for the project. This work belongs mainly to the materials side of the construction operation, but it directly affects the working area. If padding or aggregate is not available when needed, trenching, lowering in, backfilling, and access work can be delayed, which means material production, hauling, and placement must be coordinated with the field construction schedule. Pipe hauling and stringing. Once the right-of-way is prepared, pipe must be moved from the material area to the working area. This activity includes unloading, handling, hauling, and stringing pipe along the route. Pipe joints are placed beside the trench line in the correct sequence, so bending, line-up, welding, and installation can proceed efficiently. The work requires careful handling to avoid damaging coating, pipe ends, or identification markings. Pipe stringing is a logistics-heavy activity because it connects procurement, storage yards, trucking, field access, and construction productivity. If pipe does not arrive at the right location in the right order, welding crews can be delayed and the entire production sequence can be affected. Bending and setup. Pipeline routes rarely follow a perfectly straight or flat path. The pipe must be shaped to match curves, elevation changes, slopes, road crossings, river crossings, and terrain conditions. Bending crews bend selected pipe joints according to engineering requirements and field layout, while setup crews position the pipe so it can be lined up and welded correctly. This work must be accurate because the pipe must fit the route before trenching, lowering in, and tie-ins occur. Poor bending or poor setup can create alignment problems, rework, coating damage, welding delays, or installation difficulties. Bending and setup are where engineering alignment meets field reality. End preparation and line-up. Before welding begins, the pipe ends must be prepared. End preparation may include cleaning, beveling, grinding, inspection, and removal of any condition that could affect weld quality. The line-up crew positions the pipe joints and aligns them correctly for welding, using clamps, supports, spacing, and alignment controls so the weld can meet specification. This stage may look simple, but it has a major influence on welding productivity and quality. If end preparation is poor, weld rejection can increase, and if lineup is slow, the welding crew loses time. End preparation and lineup turn individual pipe joints into a ready-to-weld pipeline string. Welding. Welding is one of the most visible and critical activities in pipeline construction. Pipe joints are welded together to create long, continuous sections of pipeline. Welding may be manual, semi-automatic, or automatic, depending on the project, terrain, specification, and construction method. Each weld becomes part of the permanent pressure system, which is why welding production, weld quality, repair rates, inspection progress, and crew productivity are closely monitored. Welding is not only a technical activity, it is a major cost driver and schedule driver. A productive welding spread can move the project forward quickly, while poor welding performance can slow the entire construction sequence. Weld inspection. After welding, the welds must be inspected to confirm that they meet the required code, specification, and project quality standards. Inspection may include visual inspection, non-destructive examination, radiography, ultrasonic testing, weld mapping, and repair tracking. Rejected welds must be repaired and re-inspected before the work can continue. Inspection results affect production because coating, trenching, lowering in, and backfilling depend on accepted welds. Weld inspection also creates permanent quality records for the final turnover package. A pipeline may be buried and hidden from view, but the inspection records remain as proof of construction quality. Field joint coating. After a weld is accepted, the exposed joint area must be protected. This is where field joint coating takes place, as crews clean, prime, and coat the welded joint so the pipeline has continuous corrosion protection. The coating must be applied correctly, inspected, repaired where needed, and documented. Holiday detection, sometimes called jeeping, may be used to check for coating defects. This work is essential because the pipeline may operate underground for decades. A weak coating system can lead to corrosion risk, integrity problems, and future maintenance issues. So field joint coating may look small in the sequence, but it protects the long-term life of the asset.